You're listening to a special AI-powered training session generated based on my original research and training documents. While the voices you are about to hear are AI-generated, the insights come directly from my verified material.
Welcome to the Epic Zero Show. Today we are unpacking Module 1.2.3, Expert Systems Boom and Second AI Winter 1980-1993. This isn't just a history lesson, it's a strategic playbook for anyone building with AI today.
So here's how we're going to break this down. First, we'll look at the core promise that kicked this whole thing off. Then we'll dive into two pivotal systems that tell the entire story of its rise and fall. We'll examine the investment bubble they created, the four specific reasons it all came crashing down, and most importantly, we'll pull out the direct lessons for leaders operating in 2026.
You have to understand, the idea behind expert systems was a complete game changer. For the very first time, we thought we had a way to bottle lightning, to take the rare intuitive knowledge of a world-class expert and scale it infinitely. It was the first truly viable plan for AI at an industrial scale. And the architecture was, well, it was brilliant in its simplicity. You had two distinct parts. First, the knowledge base. Think of this as a textbook. It's just a library of I-then rules. Second, you had the inference engine. That was the brain, the reasoning part that actually applied the rules. This separation was the magic trick. It meant you could update the textbook without having to perform brain surgery on the reader.
Look, if you want to understand this whole era, the incredible boom and the devastating bust, you really only need to know two names, Mycin and XCon. One proved the technology could work, and the other was a warning that success could be its own poison.
And when you put them side by side, the story just tells itself. Mycin was this technical masterpiece. It could diagnose medical conditions at an expert level, but it never saw the light of day. Too much legal risk. Then you have XCon, a monster commercial success, saving its company millions of dollars a year, right before it collapsed under its own complexity. One proved the science was sound. The other proved that success itself could be fatal.
Let's be clear, what Mycin did was incredible. It used about 600 rules to diagnose complex blood infections. It even had a clever way to handle uncertainty, using something called certainty factors to weigh evidence. The result? In trials, it actually outperformed junior doctors. This was the moment we proved a machine could go head-to-head with a highly trained human and win.
So if Mycin was the proof of concept in the lab, XCon was the proof of value in the real world. $40 million. That was the annual savings for Digital Equipment Corporation. This wasn't research funding. This was cold, hard cash on the bottom line. XCon is what made the business world suddenly take AI very, very seriously.
So, if it was so successful, why did it die?
It drowned in that success. Its rule base exploded from 750 to over 10,000. A single new rule could create a cascade of unpredictable failures. Every new computer model they released meant a painful manual update. The system just got brittle. It became a house of cards. Its own complexity made it impossible to maintain. Now, that kind of success doesn't just stay in software. It created a feeding frenzy. A whole new hardware industry sprang up to support these systems, and right on its heels came a classic textbook investment bubble, fueled by pure hype.
The money was staggering. By the mid-'80s, these new AI companies, names like Symbolics, LMI, Technology, had a combined market cap of over $1 billion. $1 billion in 1985 dollars. This was no longer a niche academic field. This was a mania. And at the heart of it all was this specialized piece of hardware, the Lisp machine. It was a computer built from the silicon up for one single purpose, to run AI programs written in the Lisp language. And they were beautiful machines, powerful, elegant, and for a brief moment, they were the future.
And then the floor fell out. The collapse was swift, and it was brutal. It kicked off the second AI winter, a long period where funding dried up, and the term AI itself became toxic. We need to dissect the four distinct factors that caused this. See, it wasn't just one thing. It was a cascade of failures. A human bottleneck in just getting the knowledge into the system, a technical failure of brittleness when facing the real world, an operational failure of unmanageable maintenance, and finally, a total economic collapse of the hardware market. The first domino was human. They called it the knowledge acquisition bottleneck. They even invented a new job for it, the knowledge engineer. Their job was to interview an expert for months, even years, trying to translate a lifetime of human intuition into rigid if-then statements. It was slow, it was expensive, and often it was simply impossible.
Next came the technical failures, brittleness, and maintenance. A human expert, when faced with something they've never seen, gets confused. They degrade gracefully. These systems didn't. They just broke. They failed completely, catastrophically. This brittleness made maintenance a waking nightmare because fixing one problem could secretly create 10 new ones.
And the final nail in the coffin was simple math. A list machine could cost you up to $150,000. At the exact same time, a powerful Sun workstation was about 20 grand and a decent PC was 3 grand. The economics were undeniable. Commodity hardware made these beautiful, specialized AI machines obsolete overnight.
So why does any of this matter? Because not a single one of these problems has gone away. They've just changed their names. Understanding this history is a strategic imperative for any leader building with AI in 2026. That knowledge engineering bottleneck, it's still here. Today, we call it prompt engineering. We call it the teams doing RLHF data labeling. It is still a slow, expensive, human-in-the-loop process. And it is still the primary bottleneck to progress.
Brittleness and maintenance are absolutely still with us. An expert system failing on an edge case is an LLM hallucinating. The maintenance nightmare that was XCon is now concept drift, where your model slowly gets worse as the world changes. The lesson here is tactical. Budget for it. Assume 20 to 30% of your project cost is just for keeping the lights on.
And the fall of the list machine companies, well, that's the ultimate cautionary tale about vendor lock-in. The modern list machine isn't hardware. It's a proprietary cloud API. As a leader, you must design for portability. You must avoid building your entire strategy on a single closed platform you don't control. The lesson is not that rules are useless. It's that systems based only on rules are too fragile. The correct modern architecture is a hybrid. You use a large language model to generate possibilities, and then you use a simple, auditable, rule-based system to validate for safety and accuracy. Generate, then validate. It gives you the best of both worlds.
And finally, a lesson in communication. In the 90s, the word AI became poison. Today, it's overhyped. As a leader, precision is your best tool for managing expectations. You are not building AI. You're building an LLM-powered search function. Specificity grounds your team, your budget, and your stakeholders in reality.
And that brings us to the final question. XCon didn't fail because it was a bad system. It failed because its own complexity became unmanageable. This is a timeless law of engineering. So the question you have to ask your teams is simple. Are you managing your complexity for the long term, or are you accidentally building the XCon of 2026?